Circuit theory, nodal analysis. Topic: nodal analysis questions. The circuit given in figure. Shown circuit. The circuit consists of mesh 1, mesh 2 and mesh 3 and mesh 4. Noted mesh 1, mesh 2, 3 and mesh 4. Current mesh currents are I1, I2, I3, I4. Noted in circuit. 18 volt and 24 volts, 5 volts and 5 volts and 6 volts power supplies and 5 ampere current sources. For the above circuits, determine the current through 1 ohm resistor by mesh current method. Mesh current method. Method 1. Mesh 1. Mesh 1 contains 3 and 2 ohm resistance. So put 3I1 plus 2 into I1 minus I2 plus 5 minus 18 is equal to 0. Rising voltage, put negative sign, minus 2 plus 18. So minus 18. Drop voltages, put positive sign in left side. So plus 5. We obtain first equation. Mesh 2 contain 1 ohm resistance and 2 ohm resistance and 1.5 ohm resistance and 2 5-volt sources and 6-volt sources. From this mesh 2 we obtain 1 into I2 minus I3 plus 6 plus 1.5 into I2 minus I4 minus 5 plus 2 into I2 minus 1 is equal to 0. Minus 5-volt sources are go to minus 2 plus rising voltages, so put minus negative signs. We obtain second equations. Mesh 3 contain 5 ampere sources, so I3 is equal to 5 ampere. Mesh 4 contain 6 ohm and 24 volt sources, 1.5 ohm resistance and 5 volt sources. We write equation 6I4 plus 24 dropping voltages, so plus and plus 5 dropping voltages, plus 2 minus, so plus and plus 5 plus 1.5 into I4 minus I2. 1.5 across 1.5 ohm current I4 and I2 dependent. So 1.5 into I4 minus I2 is equal to 0. Only find fourth equation. Put I3 is equal to 5 ampere into. Only find second equation. From first, second and fourth equation we write matrix format of I1, I2, I4. From this matrix format, using matrix formulation, find determinant value and in cofactor matrix value and multiplication of matrix value. Only we find I1, I2, I4 value. Answer: I1 3.59, I2 is equal to 2.475 ampere, I3 is equal to 5 ampere, I4 is equal to minus 3.37 ampere. That is mesh currents. Current through 1 ohm resistor is I1 ohm is equal to, that is depend on mesh current 2 and 3. So we put I1 ohm is equal to I2 minus I3. I2 and I3 are opposite direction. So I2 negative signs are put I2 minus I3. 2.475 minus 5. I1 ohm is equal to minus 2.525 ampere. That is answer. We find 1 ohm resistance in this circuit. Node voltage method. Second voltage method. Questions shown in figure. The previous circuit is given. The previous circuit consists of, we put node points 1 and 2 and reference point. Nodal voltage method. At node 1 apply KCL method. Voltage is plus 2 minus, put add sign. Hint: plus 2 plus subtract sign. Example: V1, capital V1 nodal voltage minus 18 divided by 3. Nodal voltage plus minus 18 volt, that is plus 2 plus V1 plus 18 voltage plus So put V1 minus 18 resistant divided by 3 plus 5 voltage plus 2 minus, that is drop voltage plus 5 plus V1 minus 5 divided by 2 plus V1 minus 6 minus V2 divided by 1 is equal to 0. Apply KCL, Kirchhoff's current law. Apply Kirchhoff's current law. At node 2 depends on nodal voltage V1 and V2. So lastly we put V1 minus 6 minus V2 divided by 1. We are find at first equations. At node 2 we find equations. Node 2 depend on 1,5 ohm and 6 ohm and 1 ohm resistance. So V2 plus 5 sources divided by 1.5 plus V2 minus 24 voltage sources are metered node 2 divided by 6 ohm plus V2 plus 6 minus V1 divided by 1 ohm is metered 2 is equal to 0. Previously at node 1 3 and 2 ohm and 1 ohm resistance are metered node 1 and 5 voltage sources and 8 voltage sources and 6 voltage sources and another 5 voltage sources are metered node 1. 5 ampere source metered node 1. At node 2 we only find second equations. From this first and second equations we obtain matrix format of nodal voltages V1, V2. From this matrix format we find nodal voltages values V1, V2 values. From this V1 nodal voltage V1, V2 values we find I1 ohm. We first find I1 ohm formula from this circuit. I1 ohm depends on the nodal voltage V1, V2 and 6 voltage supplies and resistance 1. So put V1 minus 6 minus V2 divided by 1 is equal to minus 2.53 amperes. I1 ohm resistance we are finding. From first method mesh current and second method nodal voltage method we get same current value, that is important. Thank you. Node voltage method. Previous circuit I explain again how to form nodal voltage equations. Consider node 1 first. Node 1 3 ohm and 2 ohm and 1 ohm resistance are made and sources 18 volt, 5 volt and 6 volt sources are made and 5 ampere current sources are made. So we use formula V is equal to IR, Vg is equal to I. At node 1 using Kirchhoff's current law, the algebraic sum of the current at any node is equal to 0. Using KCL we form first equations. First resistance 3 ohm 1 by 3 into nodal voltage V1 put minus sign 18 volt plus 2 plus voltages we put minus sign. So V1 minus 18 divided by 3. 5 ampere source away from this node 1. So put plus 5 plus V1 minus 5 divided by 2. 5 voltage sources are connected plus 2 plus. So put minus 5. So V1 minus 5. resistance are 2. So V1 minus 5 divided by 2 plus node 1 point, consider 6 volt source plus 2 plus we put minus sign. So V1 minus 6 and V2 are opposite dashes, so put minus V2 divided by 1 ohm resistance is equal to 0. Using Kirchhoff's current law, put 0. That is first equation. At node 2, how to form equations. Consider node 2 that consists of 24 volt source and 5 volt source and 6 ohm resistance and 6 volt source, 1.5 ohm resistance and 1 ohm resistance, and V1 nodal voltage sources. First consider 1.5 ohm 1 divided by 1.5 into node 2 V2 nodal voltage plus 5 plus 2 minus sign, voltage put add sign. So V2 plus 5 divided by 1.5 plus nodal voltage V2 minus 24 divided by 6. Consider 6 ohm resistance and 24 voltage source. Nodal voltage V2 minus 24 we are put minus sign for plus 2 plus voltage source. So V2 minus 24 divided by 6 plus nodal voltage V2 plus 6 minus V1 divided by 1. 1 is 1 ohm resistance. V2 nodal voltage at node 2 plus 6 for plus 2 minus, put add sign, so plus 6. V2 and V1 are opposite dashes, so put minus V1 is equal to 0. For KCL law apply. Hint, voltage plus 2 minus, put add sign, plus 2 plus put subtract sign. That is formation of node voltage equations. Thank you.